Seems like
No,
we're
it's
live.
not.
Just going to post to stream up on LinkedIn. Stream up on LinkedIn. We are live. Up on LinkedIn. We are live. Oh yes. We are live. We're live. We need to find a good icon. We're live. We need to find a good icon. Let's go with the smiley face. A happy guy. 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 Smiley face. Alright, we are live. Alright, we are live. Today, I'm gonna be focusing on doing something from a feedback video that I got. So I'm very thankful that someone is watching, and that you have a request for me. Excellent. So this is the request. Could we model? So this is the request. This equipment. Could we model? So it seems to be a robot sliding through the going up.
So let's see what we have. We had the taxis. We had someone yesterday asking like, yeah, but taxis.
3 bags. When 3 bags are in that position, robot has to pick the 3
We had
bags.
the taxis. We had someone.
Robot puts them in the conveyor on the side,
We had someone.
and then go and pick them 3 on the side, and it will move along incrementally. It will move
Someone yesterday asking like, yeah, but what about statistics?
to be able to place
And we ended up having statistics.
the next line of bags.
And we ended up having statistics.
So actually, I got the request to do this in plant simulation. But I haven't been streaming much in visual components, and I like to work in visual components as well. So I will. Today I will do it in visual components, and perhaps the next time I will try to do the same application. In plant simulation. So here we go. So what do we need for this? So what do we need? Looks like we're gonna need a robot on a gantry. So what do we need? Looks like we're gonna need a robot on a gantry. And a conveyor. And since the robot is moving and the conveyor is attached on the robot, it will also be moving. I am not really sure how I'm gonna do it. So this is you're getting the raw experience of trying to head into uncertainty and do this. So I have some idea of where to start. I will not be using process modeling for this. I will be trying to do it the old-fashioned way. Because that's what I like. Okay, let's start with grabbing a feeder. So we can feed the bags. So we can feed into the simulation. And we will only be feeding those bags. Let's use the advanced feeder because it was on the top. Then we need some conveyors. So models by type, conveyors, visual components. Models by type, a conveyor like this. Make it a bit longer. Looking good. Make it a bit longer. Now we're getting this stuff. Let's see if we can search for it. Bag. Find something that looks better. Oh, this looks really good. Chips. Oh, this looks really good. Chips. Oh, this looks exactly like the bag in the video. Almost. It was more square. Almost yellow. It was more square. It's gonna work fine. If you can set the size of this. If you set the length to be twice as if you set the length size be twice as, but I am interested in attributes that describes its length as well as its width as well as its width. But let's go with this then. And now I don't want to use that feeder because I know there is another feeder. And now I don't want to use that feeder. Shape feeder or something that you can point to this one feeder or something. Shape feeder, point to this one feeder. I think it works like this, that if you connect that feeder, you're gonna get a regular that feeder box. But if you take that one and attach that to the feeder, I think it's gonna feed this one. Attach that to the feeder, I think it's gonna feed. It did not do that. Is there an option to do that on this one? Is there an option to do that on this one? Is there an option to do that on this one? Is there an option to do that on shape feeder? Maybe that was the wrong feeder. Maybe that was the wrong feeder. So feeder. Maybe that was the wrong basic. So feeder. Maybe that was the wrong basic. Maybe it's the pattern feeder. Basic. Maybe it's the pattern feeder. Basic. So this one will feed whatever is attached to it. So this one will feed whatever is attached. Let's search for the bag. Bag of chips. And attach bag of chips to that feeder. And attach bag of chips to that feeder. And that doesn't work either. My god, that doesn't work either. My god, that doesn't work either. Okay. Detach. Okay. Attach. Detach. Okay. Attach. Nope. Okay. Nope. Okay. Then let's show in Explorer. Let's show in Explorer. This is the chips v2. So let's find. So let's find that file. And let's take another feeder. And let's take another feeder. Advanced feeder. Okay. Advanced template components. Advanced template components. I'm gonna work with the first template component. I'm gonna work with the first template component. I'm gonna work with the chips version 2. I'm gonna work with the chips version 2. Now we're getting the chips bag. Chips version 2. Now we're getting the chips bag. Alright. Now we're getting the chips bag. Alright. And over here we're gonna have. And over here. Yeah, what do we see in the video? We're gonna have. And over here. Yeah, what do we see in the video? We're gonna have. There seems to be a conveyor underneath.
Where do we leave?
There seems to be a conveyor. The robot on the end is sliding along. Let's see the robot. Let's see. I recognize that robot. But I don't know. I recognize that robot. Which brand it is. But I don't know. I recognize that robot. Which brand it is. But I don't know. It was a yellow one. Which brand it is. But I don't know. It was a yellow one. It was a yellow one. It was a yellow one. Let's see if we can quickly just scroll through the library and find. Just scroll through the library and not that yellow. Just scroll through the library. It's not important, but it's nice to have something that looks like the video. It's not important, but I know it's not those. Looks like the video. It's not important, but it's. I'm gonna stop here. I don't know what brand this is, but let's. I'm gonna stop here. I don't know what brand this is, but let's. I'm gonna stop here. I don't know what brand this is, but looks good enough. I'm gonna stop here. I don't know what brand this is, but looks good enough. And then robot looks good enough. And then robot positioners. And then robot positioners. A robot floor track, or a robot gantry. A robot floor track, or a robot gantry. Maybe it's the floor track, or a robot gantry. Maybe it's. Then we have some new ones that I haven't seen before. Maybe it's. Then we have some new ones that I haven't seen before. Maybe it's. Then we have some new ones that I haven't seen before. So if the robot clicks on there, so if the robot that's nice clicks on there, so if the robot that's nice clicks on there. And then we need to place the gantry sort of. And then we need to place the gantry sort of on the conveyor here. on the conveyor here. Can we modify the looks of this, because this doesn't look like it here. Can we modify the looks of this? Not that it's super important, but not that it's super important, but not that it's super important. Yeah. So how the gantry works is it's built up with joints. So how the gantry works is it's built up. This joint here you can slide back and forth. So it's built up. This joint here, then you can see the joint value. This joint here, then you can out here to the left. So over here the value is 0. Out here to the left. So over here, and then it's growing up like this. Out here to the left. So over here, and then it's growing up like this. So what we need in this application is a conveyor. So that is attached in this application is a conveyor to the sliding gantry. And it sort of to me looks like this whole thing in the bottom is in the way. To me it looks like this whole. So it's gonna look a bit in the way. So good. So we can just hide that geometry for now. We can just hide that. Maybe that is alright. But I don't like those. Maybe that is alright. But I don't like those. I'm gonna look at the video one last time. But I don't like those. I'm gonna look at the video one last time. But I don't like those. I'm gonna look at the video one last time. But I don't like those. I'm gonna look at the video one last time. Okay. I'm gonna look at the video one last time. Okay. So let's hide also that. Okay. So maybe this is alright. We can make it a bit wider, perhaps. Base height 150. Wider, sure. Base height 150. Wider, sure. Don't we have anything for the width of it? Doesn't seem like it. Anything for the width of it? So I want to make it a bit wider. So this is. I want to make it a bit wider, like so, and then we scale. I want to make it a bit wider, like so, and maybe along X. I want to make it a bit wider to make it twice as wide. X. And make it twice as not X. And make it Y, and maybe 2 is a bit much. And Y 1.5, 2 is a bit much. And don't use a comma. Use a dot. And don't use a comma. Use a dot. And don't use a comma. Use a dot. And now we can slide this back and forth. And now we can slide this back and forth. Can we make it longer? And now we can slide this back and forth. Stroke X. Twice as long, no problem. So if it's growing in this direction, I actually want to So if it's growing in rotate it around, I think. So if it's growing rotate it around when the joint is in 0. So when the joint is in 0. So when the joint is in 0. So when the let's make this longer. Like so. And we're gonna need a conveyor attached, and we're gonna need a conveyor following along. So we need a conveyor where we can fit 3 bags following along. So we need a conveyor where we can fit 3 bags. So how long is a bag? A bag, how long measure it? Bag, a bag, how long measure it? Bag, a bag. We can see it's 220 by 348. See it's 220 by 348, and the bag has a property where it says length 440. The bag has a property where it says length 440. The bag has a property where how can the length 440 be 440 millimeters? Be 440 doesn't make sense. Okay, when I measure it, it's 350. Okay, when I measure it, it's 350. So let's. Okay, when I measure it, it's 350. So do a conveyor. When I measure it, it's 350. So do a conveyor and attach that conveyor on here. I'm not sure that this is the way to go. On here. I'm not sure that this is the way to go. On here. But let's try. But let's try. But let's try. So we need it to be the length of 3 bags. So 350 by 3. 3 bags. 1050. So 350 by 3. Let's make it 1100. And as I remember it from the video, this what up here was a roller conveyor. This what up here was a roller conveyor. This what up here was belt. Let's go to roll conveyor. And belt. Let's go to there is no height. And belt. Let's go to there is no height. Width. Height should be 0 for this one. And we don't want to show the legs. And we don't want to show the leg support. And we don't want to show the leg support. So you take this. move it up to the robot here in the center, move it up to the robot here in the center, reset some stuff, the robot here in the center, reset some stuff, then reset some stuff, then place it like so. Maybe move the robot a little bit closer. Maybe move the robot. How close is it on the video? It's quite close. Is it on the video? It's quite close. Is it on the video? It's quite close. I'm getting a phone call, so I'm just gonna pause the streaming. I'm getting a phone call, so I need to take this. Pause the streaming. I'm getting a phone call, so I need to take this. Pause the streaming. I'm getting a phone call, so I need to take this. Tjena! I'm getting a phone call, so I need to take this. Tjena! I'm getting a phone call, so I need to take this. Ett rejält eko. Det får vi fixa. Ett rejält eko. Det får vi fixa. Ett rejält eko. Det får vi fixa. Aha! Rejält eko. Det får vi fixa. Då ska vi se hur vi kan fixa det då. Då ska vi se. Men det är bra, du fixar det. Hej. Men det är bra, du fixar det. Hej. Men det är bra, du fixar det. Hej. Men det är bra, du fixar det. Hello. I just got a phone call that there is an echo in the chat. I just got a phone call that there is an echo. Hello. Chat. I just got a phone call that there is an echo. Hello. Chat. I just got a phone call that there is an echo. Hello. Chat. I just got a phone call that there is an echo. Hello. Chat. Hello. Now I'm trying to listen to my own chat. Hello. Now I'm trying to listen to my own chat. Hello. Is there an echo? Now I'm trying to listen to my own chat. Is there an echo? Now I'm trying to listen. Your sound is messed up. Is there an echo? Your sound is messed up. Is there an echo? Your sound is messed. Let's see what we can do about that then. Is it because I have two microphones? For some reason. If I turn off this microphone in my headset, is it better then? Okay, you're writing that the sound is better. I'm keeping an eye on the chat for now, so just let me know if there are any issues. Okay. And let's raise it up a bit higher, like so. So we have that, and let's attach that conveyor onto the part that is moving. So that conveyor is going to move along. And then we had a slope. So let's do the sloping conveyor. And I'm gonna modify a regular one. We don't want the legs. So no height on that one and no supports. And we can drag that over and attach it. And then outer properties is on. I don't want that. I want it to be a belt. Like so. But now I want this to tilt. And the way to do that, or one way to do that, is to head into modeling. And if we look on the frames that are defining the conveyor, we have the end frame here. And the red, the end frame, this one, let's rotate that end frame by, is it if I rotate it down that it's gonna be what I want? Huh, yes it was. So now I just rotated one of the frames, so now it connects like this. I think that is a bit too steep. So we head into this frame and we look at that. So I gave it a rotation of -39. So maybe go with -20. 20 instead, and then I need to reconnect it. But now I really destroyed it. That was not my intention. So maybe I should reset the changes I did there. And what happened now? I can't explain this. There is something funky business going on. Let's delete that one, drag it in and do it again. The height is 0. No supports. Plug it in. Make it a belt. Go back in here. So wherever the end frame is, here, give it a rotation of -20, maybe -17. And now I think it's going to go the wrong way. Okay, so -17, let's make it 17. Does that look like the video? Maybe. So these two are connected. Let's see now if what happens if I attach this one to that conveyor. So if I interact, I get the behavior that I want. And now, I'm not sure what to do. So what I need to make happen is I need to make the bags go up on this conveyor. But how to do that? This is a tricky part.
Yes,
So
today's part.
what happens is
I'm not gonna do a super long stream today.
you have
Like,
this one standing still and it's waiting for a
even though
bag. And then it's moving and standing still and waiting for a bag. I wonder if we could connect the interfaces of this conveyor to the interface of this conveyor and have the positions of those interfaces move. That would be one way of doing it. So what I mean is, this bottom conveyor, it has an interface frame here that we want to be here and connected to this one. So I'm gonna attempt to... So then when we start programming this and controlling this robot, we could simply move that frame along. I don't know if it's gonna work. If it's not gonna work, we're gonna find a workaround. But for now, I'm gonna go into this one and I want to move the position of that. So how long is this? Let's make this 15 meters long. And then we have the position of the end frame. Start frame and the end frame. So the end frame is over here. And let's do something with this one that you're moving the end frame to the end of the conveyor, and you have a conveyor end offset. So maybe we can use that one. So conveyor end offset, conveyor start offset and end offset. So if we make this -2 2000. That frame was moved over here. And that interface is now here. So if we make that, move that again, it's moving the interface. And what happens if we click play? So let's click play and change the position from -4 to -5000. It actually moves during simulation. So maybe this is gonna work. So now my question is, how much more should I move it? So I should move it from here to over here. Red line is 49, 42. So -49, 42. Boof. And then it jumped over here. And now I should be able to plug this conveyor into that. But then we get this. Let's see if we can also rotate that one, the start frame, in the same way. So let's tilt it down. So in the parent we would maybe want to do minus, was it 17? Oh, okay, plus 17. And let's go. I'm gonna make this a little bit longer, and reconnect it again. And a little bit longer. So I'm gonna move it down like so. This is not to make it look realistic, this is to actually have the frame being on the correct height, more or less, so that it will auto connect. It's still not connecting here. Okay, so I want to have it here. So I need to measure the offset again from here over to where the frame is here that I cannot see. It's here. I want it to be here. So here, and let's move it little by little. -250, -50, and now they're very close. Let's see if they can connect now. Now it's connecting up here and it's connecting down there. And what happens if I move this now? So plus 1000, it's gonna jump, but is it gonna stay connected? So if we have the bags rolling in, it's going to where that interface is. So if I move the interface plus 1000 again, it actually dynamically moves now over here. But then I think we lost the connection between this conveyor and that conveyor when I moved the interface during simulation. So maybe this is not the way to go. I'm not giving up on it. I'm not giving up. So this robot position, it's now positioned at 2675. 2675, and that seems to be a good starting position. So when it's here, or maybe this is the starting position when it's in this end here. So 0. So when this is on 0, I want this interface to be here. So how can we do that? So this is the bottom conveyor. I'm gonna call it the bottom conveyor. So whenever this is moved, I want to set a property on this conveyor to move that interface. And I still don't know if this is going to work. So I think this robot here is going to have a Python script. Python script. I'm going to call it recog script. And in here we can access the references and search for how we program the robot. So I know there is a VC robot, VC helpers 2, and they can scroll down to the example code down here, and here it shows you how to control a robot via code. So I'm going to grab this example code. You get some imports. The robot is get robot. Okay. And you usually want the component for something, so get component. And this is the script that's gonna make this robot do something. So the task I'm gonna make a while true loop, and this while true is gonna be the working loop that's responsible for work loop place bags 3 by 3 in a container. And we're going to trigger this robot to lift these 3 in when there are 3 things to pick up. So this conveyor is called conveyor 2. I'm going to call it conveyor by the robot, so conveyor robot. And I want to have an access to that in the code, so that would be app.find component conveyor robot. And this conveyor robot, it's going to have a path that you can we could do this with signals. It would probably be a little bit better that this signals to the robot every time something enters. So how are we gonna set this up? What I'm gonna do on this conveyor, I'm gonna do this really nice. So on the conveyor is simply gonna throw a signal every time something enters, and when we've counted to 3, we're gonna pick them up. So this is a Python script on the conveyor itself. So comp is get component, and the path is comp find behavior path, and every time something enters the path, so path on transition is going to be, we call on trans method, where we're gonna get the part and a boolean if it arrived. So if something arrived, you want to activate the signal. So I'm gonna have an arrive signal. I'm gonna call it arrive signal, and this arrive signal is what we're gonna use So the arrive signal, and if something arrives, then arrive signal true. So this is a simple way to just signal something arrived, something arrived. Okay? Are these two still connected? No, they're not connected. Can they be connected now? And they are not connected now. So there is something here that is acting up, and I'm suspecting that trying to move the interface like this is not gonna really work. What to do then? Oh, maybe this was more tricky than I thought. Ah, but it's not connected. Why is it not connected? Ah, it's because I moved the interface, of course. So let's try that one again. So when is stuff arriving? It's arriving at 18 seconds. So I'm going to put in 18. So when we reset and click play, we're never going to have to wait again. And now it's going upwards. And now it's going down there. Seems to be working. And the script on this conveyor is not working because we're trying to find the arrive signal. So we need to create that one. So a Boolean signal, call it arrive signal. And the question is, do I need to reset that signal? We'll see about that. So arrive. We already have the transition signal. Maybe I should use that one. Maybe my Python script was completely unnecessary. We will see. So back to the robot. While true, we want to listen to signals. So let's define the on signal. And on the robot, I'm going to create a signal in here that is going to be the robot's version of that arrive signal. I'm going to call it bag arrive signal. And then if we take up the signals connection thingy, we have the bag arrive signal that we can connect to the transition signal. Let's try the built-in one. So I'm gonna do that each time the robot receives a signal, if the signal.name is equal to bag arrive signal and sig.value, it means I only care about the true values, I only care about content in here. So if there is a null value or if there is a false value, I'm not interested. Sounds good. So, and then each time something arrives, I'm gonna have a global queue here, and to queue I'm going to append something. Append a 1 just for the sake of it. Queue append 1, And I know that when I append stuff to the queue, so each thing in the queue is going to represent a bag. So I want to start the robot, I guess. So if the length of my queue is equal to 3 and not running, resume run. So not running means if the robot is busy picking 3 bags, then I don't need to tell it to start running because it's already running. So we need a global running. Let's put them also in here. And the first thing I want to do in the work loop is if the length of the queue is less than 3, then I don't want to work. So then I'm not running, and then I simply wish to suspend run, like so. But if we resume run, it's gonna start the code here. Then I am running again. And now do the task of picking the 3 bags. And the 3 bags are gonna be on the path of the conveyor robot. So I'm gonna have a handle to that path, conveyor robot.find behavior by name. And what was the name? Was it name path? Yeah, the name is path. So so get the path of the conveyor for the robot. Okay, so the path. So here I want to do a check first. So if the length of my queue is more than 3, then I want to print error. Too many bags, max 3. So that is just a little check. It's gonna be nice if something goes wrong. So if I'm trying to pick more than 3, then throw me some errors. And then we could also pause the simulation because we don't want to run the simulation with errors. So put in a little sim halt there. So first we want to position the robot over the bags. Over bags. So that's going to be a robot. Move to a certain position. And I think I'm going to program the robot manually. And it's going to need a gripper. So a gripper. Where do we find the grippers? Robot tools. And we're going to go into the visual components. And as I remember it, suction mechanical gripper. I remember something about it being like a big hand being able to pick up 3 bags. Parametric box gripper. Maybe that will do. Put that on there. So what does it look like in the video? It looks like he's going over like so, and then the hands are very long to cover the entire conveyor. So if we go into program, select a robot. Okay, let's do this robot. Create a new sequence. Call it default. Oops. I'm calling it default because I want this to be the default position of the robot when it's not working. And it's gonna make sense in a while. And this is the gripper. I needed to attach that to the robot. And now I'm saying that an output of on 1, on true should be grasp, on false should be release. And jogging, I want the tool to be the gripper tool that's attached. And did things have, here is the move tool, okay. I don't want to do that. I don't want to move the gripper, I want to jog the robot. My bad. Jog. But that's not what I want to do. I want to be jogging the robot. The tool lost the config. So the gripper tool, now this is what I want. So I can grab the TCP, the tool center point, and say, let's go to the center here somewhere. Let's find a center. That looks like a nice center. And reset the position, no rotation like so. And I don't believe I want rotation here. Okay, let's go down like so. Let's go up. And now I see I need to rotate it like so. So that's going to be 90 degrees here. And I just want to find out how to set up my gripper. So the gripper should be much longer. How long was the conveyor? 1100, I believe. So let's make the gripper 1100. And something like that. Something like so. Programming of the robot, the TCP. Let's go down to that height and create, this is going to be the default waiting position. Gripper to 1 and null is the base. Yeah, I'm not gonna worry about the base frame. Maybe I should worry about the base frame. So reset. And now I don't understand why the robot is not moving. Because I need to be in jog. And I click the point, and this is the point that I defined. I'm gonna have that be in the base of, is it this one? So when I move, no. This here, tool, base, the robot base, yeah. The gripper and the base. But still it's null, so let's activate it like so and do a new Now I got that base to be there. And now that point is following along the base that the robot is standing on, that joint. And that is what we want in this case, because else the robot program is not going to work really. So we'll be programming in that base. So when we go here, and then maybe we want an approach position to be here, so let's create an approach position. First approach, then you go down, and that's going to be the default. So I know there is a way to get hold of that robot program and use it inside Python. Call subroutine, I think it is. So it's going to be robot.callSubroutine. Name it default, and I'm actually going to move that up before here. So the first thing we want to do is go to default. And if we click play, it doesn't work. Non-object, none. So get component. I didn't get the robot here. Is it because I need to paste in the comp? No. It still crashes on line 28. Robot. There is something about using get robot that doesn't work. Maybe the example given here is a bit old. Robot is get robot. Okay, how does it look like down here? Robot is get robot. Okay. The robot, get robot, but here we're pasting in the handle to another component. So get robot seems to be used in two ways. Either you can give a parameter or you don't have to. Okay. Let's try and not make the software upset. Get, so where can I read about get robot? Get robot creates a new VC robot object for a given component, which must have a robot executor. Do we have a robot executor on this robot? I have an executor here, so it should work. But if we paste that in, it still doesn't work. Why is this giving me issues now? So this is the name of the game. I've done this many times, but it's still giving me issues. That's how it is. You need to slow down and figure out where did you go wrong. Where am I making a mistake? Should be somewhere, because this usually works. I know I have these issues sometimes with get robot, but what is the mitigation? R is get robot. Articulated robot, okay. To me, it should just work. Maybe I'm not gonna call it robot, I'm gonna call it robo. And then robo. Can you make it work then? No. If we move get robot to be called here every time, that doesn't work either. Get robot. Okay, let's go on a side quest. Side quest is get the robot working. So we have the script and we have the gripper. I'm just going to try another robot. See if there is a bug with this particular one. So the safest bet is to use the general articulated robot, which is just a generic robot. Delete that robot, put this gripper onto that robot, and this robot onto here. And now, of course, we need to go in and put the same Python script on here. Call it recog script. Paste the same script in. And since I'm trying to call the default, which is not on this new robot, put the default in and now configure the same robot. So the base should be the tracking base, tool should be the gripper tool, and if we position it somewhere in the middle, flip it over, go up, put in a point, then put in the next point. So now we have a default thing. So if we click play, then it just works. So I did not change the code or anything, but I switched the robot to another robot. I saw that this robot had an executor, the other robot had an executor. Why does this work? I don't know. But it does. Maybe someone watching, maybe someone deep into how Visual Components works could place a message and explain why that fix worked. But I'm happy because now it works. And we have some other issues. We need the queue to be initialized as an empty queue, an empty Python list. And we have another crash on line 29, which is robo get robot. I would like robot get robot to be up here. Feels better. And now we're having maybe it is that my script doesn't actually do anything? Yes, it does. Non-type in call subroutine. Ah, I think that I know the issue. It's on the robot floor track. It's another component. Robot floor track. The recog script. Oh, I put the script on the wrong... I was trying to program the... Okay, that makes sense. Why it didn't work. And why it is working now. Sometimes you work too quickly and you make mistakes. So lesson of today, slow down. And I'm gonna put on something that is going to stop the bags as they arrive on the top conveyor. That should be a conveyor utility, I think, and it's called something like an end block. Oh yeah. Let's put on the end block. Oh, if you can snap. I don't know why my end block doesn't snap. I want it... Now it snapped. So the end block is just something you snap on a conveyor, so when something arrives to the end block, it should be stopped. Let's see it working. It works. Like so. And I think that this, we could configure the path to only have a capacity of 3. I think makes sense. Maybe we need to go into the path under the hood and set the capacity to be only 3. And I want it to accumulate like this. So now we get 3. And now I think I need to attach the signals again. Oh yeah, we should have a bag arrive signal on the robot. So I need to put that on again because I deleted the old one. Bag arrive signal is connected to my recog script. Recog script. So each time we trigger the arrive on the robot, we should be trigger this code in the Python script up here. Bag arrive is connected to that one. Let's go. Oh yeah, we got 3. And now something is doing something. The robot is dancing up and down. It's happy, I think. That's cool. So we need to expand the code, what it's supposed to do, instead of just calling it the subroutine over and over again, making it dance. So I want to grab all the 3 things on that path. So how do I usually do that with Python? Because I know I can set oh yeah, the gripper. Maybe I'm just gonna do a pick subroutine in here. So pick and pick and rotate. Let's call it that. So in pick and rotate, start here, and then we set the value of the gripper. So wait for binary, set binary. Set the first value to be true, and I want to map the out port 1 to control the gripper. So if I click the robot, I go down here to actions configuration, and I set that the output signal on true you want to grasp, on false you want to release, using the tool gripper tool 1. So pick 3 bags, pick and rotate, so I want to pick, then I want to go up here, and then we should do something like rotate the robot out here, and now I'm looking at the joint values, and that was over rotating it. Can we go to 180? Here, I want to go here, and I want to do point-to-point motion, and when I'm here I want to do a small delay 0.5, and then we want to open the gripper to be 0, then it's opening, delay a bit, then go back to that position, but have that be a point-to-point, I think. We'll see. What's gonna happen now? We are getting a feeder error. I want to remove the feeder error. It's because I have those, I think. So let's go to 18 seconds every time we click play. Oh, it's doing something. It's doing something, alright. So set out 1, and then here set it to false. And maybe I forgot to say, so 1 should be using the gripper tool. That's what I want. 1, 2, 3. And it doesn't work. We can watch the signals on the robot. So we are using an advanced gripper. Maybe we should close the gripper. And that is apparently port 102 to close the gripper. So maybe we should use 102 instead. So you always need to learn on the job every day. Learn on the job. Now I just switched which out port we're controlling. it did control the gripper, which was nice, but it failed to pick the bags. So let's again go to, was it 102? That's not 104, 102. That's not here. Okay. Parametric box gripper. When it's in the closed state or the open state. And then we have close, open. I'm just gonna do a small delay here. Delay 0.5. So it's working a bit slower. What is it with the gripper that I don't understand? Could be many things. Let's try and make it grab by Python instead of using this. So the Python grab. So we can do grasp component P in Python. Let's see what grasp component is. Grasp component, or you can grab a list of components. Ooh, grab components and you paste in a list. This sounds very nice. So in the default here, we don't want to set that, we don't want to do that, we don't want to do that either. We're going to come to that in a while. We put in a hold statement. So you pick 3 bags, and now it said grasp components. So grasp which components? Grab all the components that are on that path. So grab components. And I think I need to do robot.grasp components, all the path components. This is very exciting. Are we gonna see the bags moved? Yes. The bags are in the gripper. And now we could also animate the gripper to close. It would actually be quite nice. And we did that by setting 102 to be true, I think. Yeah. Then I have to figure out how to not close so much, but we can figure that out later. And we can see that it's grabbing before this bag has stopped. So there is a distance between the bags. We also need to mitigate for that. So when bags enter, it's entering now and it's already being picked up. That's too soon. So let's increase this delay to be 2 seconds. So when you have some bags arriving, you want to wait a little bit, have it in there all the way, then close and then move. And then when stuff end up here, when the bags end up here, let's look at the video.
Where did we leave yesterday's model?
Oh,
I'm not gonna do a super long
they're
stream
being
today.
dropped,
It's late,
and they're
even
being
though
dropped
taxi services are
one
fun.
by one. So they're always dropping
Where did we leave
the outermost bag first,
yesterday's?
and then that outermost, and then the center one. Let's see if we can mimic that. So here we would like to apply physics to the bags to have them drop. Let's see if we can do that. I also want to drop them inside something. Inside some sort of box. That would be so nice. So, container. Do we have a container? We at least have a box. How long is a box? I think a box is 10 meters long. And how wide is it? Is it 1200 wide? It's at least 3 bags. Okay. Let's look at it from the top. Position it something like this. I've already forgotten the bag length. Was it 350? Yeah. Do 350 bag. Should it be a bit more up? A bit more up and make it orange, because it was orange in the video. Yeah, orange. Orange is fine. So we're here. So let's make the container start here. And does it look like it's wide enough? It looks like it is wide enough. So can we just drop them from this height? Let's see. So bags is an empty list, and for all the components in the path dot components, we're gonna append them in the same order. What did I do? Did I remove something important? Yeah. So we want to keep track of all the bags. And then there is a way to assign physics onto the bags. Let's search for physics. A physics converter should have that type of script on it. I think it is quite simple. Set up phys on the part. If not has physics, the physics entity is create this on the part. And then the value, physics collider. I don't think we need this. Physics collider enum, the property root feature, create the property integer, physics collider, prop value, physics collider enum. And I think this is the code that we need. Let's see. Big 3 bags. I'm gonna see if we end up, if the code ends up here. No. Why didn't it print? Print 1 and then done. I got the 1, I never got the done. So what's happening in pick and rotate? Ah, we're getting the halt here. So let's remove the halt. So we do done. Then we're gonna call that physics entity script or part of the code. So for each component, for each bag in bags list, we do add physics to the bags. Reset and start. Seem to be working. Maybe this one here needs to have a physics collider so it can collect all the bags we drop in it. So a physics entity, and that is, I think, kinematic. And if we look on this here, we can do physics collider to be a box, and this one to be physics collider box, and maybe also this one to be a physics collider box. Is this simply gonna work? Is it gonna drop it here? Yeah, it's working, but it feels that the collider is, the box is on top here. So physics, let's do precise and see if that can help us. That looked better. And I think we also want, because right now it crashes because all these boxes, they still are contained within the gripper of the robot. So this box, it does have a component container and it's called a box. So let's find the box and let's find the box component container. That's going to be the let's call it the box container. And the box container, before we do a physics drop on the bag, let's say that the box container is allowed to grab the bag. In that way we can keep track of which container, or we're moving it into the box basically, both programmatically in the container and also delivering it over to the physics system. And this was a big no. Did I destroy something? So we first got a crash on 22. The box is non-type, so the box doesn't exist. This box is called box, so a big B. I think that was the issue. And we are starting okay, let's see. We need to, this is gonna be a bit ugly, but I'm gonna do it. I'm gonna pop the queue 3 times. Pop the queue 3 times. Because we need to empty the queue or this code crashes the second time. This is looking not so good. I mean, the program is doing something, but let's restart. So let's go back to the drawing board. What do we want to see happen here? I'm gonna actually move the box a little bit. So I'm gonna measure the distance here to here. I'm gonna say it's 149. So that's the first thing. And then we're gonna fix this. Alright, 149, so maybe plus 140. Just to have the one being placed a little closer to the edge here. And then what is the width of one bag? How wide is the bag? Let's measure it. Seems to be like from here to here. We have 221. Let's say then 225. So I'm going to give that information to the robot program. I'm going to call it bag width 225. And that is how long, that is how much we want to move the gantry every time. So let's go into the gantry. It's called the robot floor track. So we're gonna look in the application for the robot floor track. I'm gonna name it floor track, and that has a servo controller. So floor servo is going to be the floor track dot find behavior, and we are looking for the servo controller, like so. Floor servo, and it should be that after we have add physics to the bags, in other words, drop the bags, and what we want to do after we've dropped all the bags is move the servo. So servo floor.servo, we want to move it with the bag width. So I don't know if I can remember this on top of my head, but set joint target for the first joint to be, so wherever the current value is. So the current value of the servo is the floor servo.get joint value of the first joint. So set the next value to be the current value plus a bag width like so, and then floor servo dot move, so position robot for next bag drop. So we get the current value and we add a bag width to it, and then we move the servo. Something happened. It goes there and then it goes back again. That was unexpected. Is that somehow because, is that maybe because the base position is part of the robot program at this point? So it could be that these actually manipulate. Okay, so bag width times 10. I'm just gonna move it 10 bag widths away. Maybe, baby. External TCP. Is that something I want to be using? Because I think the issue here is that the robot, this position that it needs to go to, it actually tells the robot track to also reset the position or something. Let's not use external TCP. I don't even know what it does. What is working against us seeing this robot behave correctly? What is the issue here? I mean, the positions are moving together with the robot. Which is nice. But why does it need to go back? Let's read the documentation again. Joint move to matrix, move to position. So this is the robot. I want to look at the servo controller. This is servo controller. So I used get joint value and then drives all the joints to the target values. Yeah, so get joint value, set joint target, I believe I use, sets the target value of joint. Set joint target and then move. We can maybe use to calculate motion time. It returns the calculated motion time. Because I don't know if if it does this after the movement has been completed or right away. So it does that, moves away, and then it prints down. So it moves to the correct place. It seems to move the robot to the correct place. It's printing moved one bag, done. Then it's calling the default subroutine. And the default subroutine is programmed in the robot track X. Maybe it should be in the robot track base. Robot track base. What happened to the point? The point is static and it's not moving along. Robot track X. Because I would imagine that if you're programming the robot base, if you're moving the base, you want the points to move along with the base. But as I'm calling the subroutine default, it's moving the robot to this position. And that seems to... now I'm seeing here in jog that we have robot floor tracks. We're actually having these ones here, but I don't want to... Yeah, so these 2 points actually contain values for the robot track. But I don't want to program the robot track. Because I want to drive the robot track with my Python code. So how do I separate those two? Okay, I drop and then we go back because that's what it is, that's what we have. I thought I could make a simple program to just turn the robot and not affect the base. Robot track X. Okay. What if there is something in this floor track that is allowing for that control to happen? So I want to be able to put the robot on there, but I don't want it to be programmable like this. So the servo controller, flange node is robot base, and then X is servo controller, robot base. So remember, for everyone watching, this is the raw experience when you try to model something, and really I have no plan, no tutorial beforehand, so I'm just trying to figure it out as I go. I'm not sure what's gonna happen if I delete this base container. Oops, I deleted it. It's still a thingy that can do that. The base is gone. And now positions are out of reach. They ended up over here because they lost the base. Let's program them in base 1. Having base 1 node be that node. Base 1. We can still control the robot floor track. That's what I don't like. I need to find a way to separate the programming of the positions here. From the position of the track. What if I take the robot and unplug it? And the robot is still going to work. And plug it back on. Now the positions are out of reach. That's one position, that's another. All these positions, let's move them back up here. So we can go here, and this position. They were out here, those should be something like so. Point 4 looks strange. Should be, I think point 4 should be where point 1 was. Yeah, let's see. Maybe we should stop using the robot programs altogether. How about that? I think that sounds like a good idea, because I don't know how to keep track of the base and program the positions and and do the things that I want to do. So I'm gonna move away from using the robot programming altogether, and that's gonna be that. Delete all of that, and now we're gonna have to start over by I'm gonna put some frames on the robot instead. So this is the robot, and in here I'm gonna create some frames. So I'm gonna call this frame pre-pick, and that's gonna have to go here and upside down. So I'm gonna position frames instead. So let's put this in the center of the gripper, upside down, and go down a bit. And this is my pre-pick. And then I'm going to have a pick. That's going to be further down. And these are going to stick to the robot. So whenever I tell the robot to do something with my Python code, it's going to reference these frames. So I don't want to use call subroutine. So remember, going default, that was me navigating to pre-pick and then pick. So I want these frames in the code so I can navigate to them. Comp, so get frames, so I'm gonna have the pick frame, comp.find feature pick, and then we're gonna have pre-pick, and then we're gonna have place, but I don't think I'm gonna have to use that. I think I'm just gonna rotate the base by 90 degrees. Pick and pre-pick. Robot move to a frame. How do we do that then? I think I have that in a layout somewhere where I am moving robots to frames. I have that piece of code lying around. Maybe we can figure it out. It is the robot helpers method. It's joint move relative, joint move to matrix, joint move to position. So we have joint move to position and linear move to position. And then we have joint move to matrix and joint linear move to matrix. And then you can give it a VC matrix. So I think that's it. That you do robo joint move to a matrix, and we use the prepick dot node position matrix maybe, and then we move to the pick node position. Let's see if that works. It's already in there. Position 1 is out of reach, and if it's not the node position, is it the position? No, it's giving me the same issue. Let's see if I can find how I did it another time. I know this one has something like that. Yeah, let's open that one. It's gonna take a while to start. But when we get that row going, then I think we should be able to... So instead of do pick and rotate, because we're already grabbing them here, we're just gonna move the robot to turn 90 degrees. And we can at least try to see which joint it is to turn it. It seems to be joint 1, the first joint of the robot. Robo, and is it, let's see what it is. Drive joints, the joint, first joint. Drive joint 1 to a value. Drive joints, okay. I'm looking for a way to move one of the joints. Drive all the 6 joints with the method. So drive joints, and then you give a value for the first one. Probably. Drive joints. to 180. Drive joints. Let's copy the code. I'm gonna stop the stream just a little bit.